Excellent. We're here for part number 4, and we have example number 2. So this should be wonderful. Obviously, this looks like an ice cream cone, right? This sure is. So let's find the volume of an ice cream cone, which has the above cone equation. 3 times x squared plus 3 times y squared equals z squared. And below the sphere, the below equation for the sphere is x squared plus y squared plus the quantity z minus a, that quantity squared, equals a squared. So what do? We got to start finding these boundaries, right? Let's start with our boundaries. Boundaries for the cone. Let's do the boundaries for the cone first, which we have right here. So we're going to plug in what? R times the sine of theta times the cosine of theta, that quantity squared for x. For y, we're going to plug in R times the sine of theta times the sine of phi, that quantity squared. And we're going to plug in for z. For z, we have R times the cosine of theta, that quantity squared. Okay, so we're going to plug these values in our equation. Okay, so the first thing we get is we squared everything. We have the 3's. We can take a 3 out on the left side of the equation. We can take an r squared out. We can take a theta squared out, and that's what we're going to be doing. And then we still have our cosine squared phi plus sine squared phi. That gives us 1, so this will be just turned to 1. So that'll drop out. And so the r squared will drop out, and we still have 3 times the sine of squared of theta, and we're bringing over the cosine squared of theta, and the cosine, 3 times the sine over the cosine equals 3 times the tangent squared of theta, which equals 1, and we're going to divide this 3 through so that we can get the tangent of the squared of theta, which is equal to 1/3, and which is the arctan of theta is equal to 1 over the square root of 3, which tells us that our angle is at 30 degrees, or at what we could say in radians, pi over 6. Excellent. So that's just one. Okay, that's just one of the boundaries. Okay, we need all the boundaries. Okay, we need our r, we need our theta, we need our phi. So we found our theta. Our phi is, again, that's simple. It's 360 degrees, so that's not hard. Okay, so now let's find the boundaries for the sphere. Okay, so we can find out what r is. Okay, so boundaries for the sphere is r is equal to r squared plus y squared plus z squared. That's the general form. And so the form that we got was r squared plus y squared plus z minus the quantity z minus a's. That quantity squared equals a squared. So let's multiply out this z minus a squared. Okay, so we still get our x squared plus our y squared. But now we got, oh yes, z squared. Good. So now we can replace this with an r with this equation. Okay, so this got to remain, which is a minus 2az plus a squared equals what? A squared. These a squareds can cancel out also. Get that stuff out the way. Okay, so like we said, this is r squared, but we said this is going to be 0. So all we have is what? Oh, yes, minus 2az. What is z? Z is r times the cosine of theta. So let's reduce it even further. We can take an r out, and then we have r minus 2a cosine of theta equals 0. Perfect. So now we can solve for r. So r is going to equal what? 0. And r is going to equal what? 2a cosine theta. So now we have all of our boundary points. Now we can begin to solve it. Our triple integration. Yes. What is so much fun? So we already said that we had 0 to 2 pi. We had 0 to pi over 6, 30 degrees. We also said we had from 0 to 2a cosine of theta. Now all of this is time what? The dv. This all has to be under dv, so we can find out what v is. Okay, and dv is r squared sine theta, r dr, d theta, d phi. Okay, so we're going to break these down again so we can see that the d phi, okay, is by itself. There is no phis in here. We have theta, so we have d theta, we have the sine of theta, and we have here the r. We have r squared dr. So let's see what we can come up with here. Okay, so we come up with 2 pi as this bottom limit goes to 0. And then we'll be able to look at the integral of the sine of d theta. And we see here that the r squared is just 1/3 r cubed as it goes from 0 to 2a cosine theta. So we have the 2 pi that stays out. We have our sine that we haven't integrated yet. So we're just looking at this other term here. And so as we plug in for 0, that'll go out. That's fine. So but this other term is to the cube, 8. That's 2 raised to the 8 power. So that's cubed. And then we have a cubed. 2, 4, 8. And then we have the cosine cubed. So now let's look at d theta. What do we have here? Okay, we take this out. This is 16 times the pi times a cubed, all divided by 3. So that's our constant that goes out front. Now we have our 0 to pi over 6. And if we integrate our sine and the cosine cubed, all right, let's use u dv. Okay, we got to use u substitution. Okay, so we're going to plug in for u the cosine of theta, du, the cosine of theta, the derivative of cosine theta is minus the sine of theta. And so if we integrate that, we plug this in, we have u cubed du and so what we'll get here is a minus 1 over 4. There should be a minus here. Because there's a minus, du is a minus sign. So we have here 1/4 u to the 4th. And so we keep out our 16 pi over a cubed to the 1/3. And we have here our minus a 1/4 times the cosine raised to the 4th power from 0 to pi over 4. And there's 4 and the 16, that'll cancel out. That'll give us 4 pi a cubed over 3. We're taking that limit here as a minus cosine to the 4th power of pi over 6 plus the 4th power at 0. We know if that's 0, it's 1. So we know we have to keep that term. And then we have our constant out front. And we have, as we said, this will be 1 minus, this is 3 over 2 to the 4th power. We have our constant that's out front times the quantity 1 minus, and if we have this cubed to the 4th power, that's 3 times 3, which will give us 9, and that'll give us 16. So it's 9 over 16 minus 9 over 16, and so we get 7 over 16 and 4 pi a cubed to the third power. So V is equal to, our volume is equal to 7 times pi times a cubed over 12. Excellent. Got through another one. Okay, so now you get the chance to practice. You have practice problems. Okay, you will have 5 of them. Volume of the conic surface whose tip is at the origin and whose base is a circle of radius square root of 3 in the x in the z equals 1 plane. Okay, so we have one, and we have a second one. That asks you to find the mass and the moment of inertia about the z-axis of a hemisphere with radius of A and the density of R. Practice problem 3. Find the integral describing the volume of the elliptoid, x squared plus y squared plus 5z squared equals a squared. The integral identified below may be used. Practice problem 4. Find the moment of inertia of a uniform sphere, shield of inner radius of A and the outer radius of B. And the final problem is an approximate model of the Earth interior structure uses 4 major layers. Estimate the what? The moment of inertia on the z-axis for the Earth. Okay, we will see you again. Thank you for spending the time with us.